We're going to look at vertical hyperbolas. And then horizontal hyperbolas. And pretty much what I'm doing for you guys is we're going to draw the diagrams for these, and I'm going to show you guys the equations, and you guys are going to use that information to answer other problems that concern hyperbolas. We did the parabolas, we did the ellipses, and now it's time to do the hyperbolas. Check this out. For the vertical, man, this looks so close to the ellipses. Look at that. It looks almost identical, doesn't it? What's the main difference?
Subtraction.
It's subtraction. You see the subtraction? Now that's important. Now I always keep the a squared on the positive fraction. So whichever fraction is the positive one, that is what tells you the most about your hyperbola. The a is positive. That's going to lead you to your vertices, and the y is a vertical axis, which clues us in on why it's a vertical hyperbola. So let's draw this guy. Now to draw this guy, draw yourself a vertical axis and a horizontal axis, and then draw a box. Your box does not have to be any particular size. I'm going to draw it like this. I'm going to kind of draw it tall. And then I'm going to put my vertice right here and right here, because this is a vertical hyperbola. After you put your vertices on there, draw your asymptotes. The asymptotes go through the corners of the box, and they go through the center of the hyperbola. The center is at our origin. Next, draw your parabolas. We have one right here, and we have one on the bottom. It's vertical because it opens upwards and downwards. Oh, I almost forgot. Focus points. There's a focus right there. There's a focus right there. All right, now let's look at the A, the B, and the C. The A is a distance from the center to the vertice. And your C goes all the way to the focus. Your B goes out to the edge of the box, and that's why the B is important. There's no co-vertices in a hyperbola, but I might say I might say this is a co-vertice every now and then, just so that we understand what we're talking about. The A and the B pretty much just give you the dimensions of our box. So the dimensions of this box from here to here is 2B, because 1B is only halfway. And then from top to bottom or bottom to top, that's 2 A's. Because remember, the A is only from the middle out to the vertex. This is how you relate the A, B, and the C. C squared equals A squared plus B squared. Doesn't it look like the ellipse? The only difference is, or are, the signs. The signs are both different. That's how you find your A, B, and C, that's how you relate them. Now for the horizontal hyperbola. Draw a vertical axis and a horizontal axis. I'm going to draw a box that's similar to my other box, because I want to show you guys and prove to you that it doesn't matter which side is the longer side. You can have the vertices on either one, the longer sides or the shorter sides. So there's my vertices. All right, let's draw our asymptotes. Make sure they go through the center. Alrighty, and then I draw my parabolas. Look at those parabolas. Alright. Yeah, what about our equation? Let's draw our equation. Now remember, with the ellipse, the A squared and the B squared would switch. Now with the hyperbola, now this is just me, and I do it this way because it helps me keep everything in order. With the hyperbola, the denominators stay the same, except the numerators are the ones that do switch. Again, look at the positive fraction. The positive fraction tells you what type of hyperbola this is, And because the x squared is positive, that means we're horizontal. Why? Because the x is horizontal. Oh, the a leads to your vertices because he's in the positive fraction. And there you have it, guys. If you can grab a blank paper and draw out these parabolas and draw their equations, their formulas, then these problems that we're going to tackle are much more simple.